This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. Hey, actually, today it seems the pipeline didn't run. I think because we didn't schedule on Saturday. Bad. Okay, let me quickly create a release and let it create the infra. So on our schedule, Saturday was not there, so that's where it didn't run. Okay, so now I just put the Saturday and also saving it. So I just kicked off the release. So let it create it. Just start it in the meantime. Prometheus also we want. Let's start that. And this instance I don't need it. So let's get the environment, and then yesterday whatever we are doing some benchmarking, right? So yeah, so we are kind of putting some load and coming up, right? So some numbers. So this is the CPU usage of last 15 minutes. Like let's say if I go for last 24 hours, like yesterday we made it, right? So, and let me look at this time. Yeah. So this is the metrics actually we found it out yesterday, right? So during our spike, this is what we understood, right? So initially we're having, so initially we were having certain problem. We were having certain problem on the memory of one service. We understood that with that one. So and later we told that we'll go with the higher instance type, and then it started stabilizing actually here, right? So so there is some saturation point actually. So beyond the saturation point, it cannot work. So that's where actually we hit with the lower instance, and we changed that to higher instance. It started working fine. Okay, only for that particular service we understood. But the next thing which we want to talk about here is so before going with the auto scaling, okay, before defining the auto scaling from the Prometheus, whatever we want to say here is from the Prometheus, what we want to say is we want to come up with some benchmark values during the load test. So in the load test, there are a lot of ways, like so step up, ramp up, certain methods are there. I don't want to talk about the load testing here, okay? So because that's more of QA job, or I mean, it's like more of a QA job basically. So that's where I want to just use it, and I want to design my infra accordingly. So in my infra, I'll say that so this instance capacities is capable of running until these number of users. Okay, or I'll come up with the benchmark value today. So staying with a small table saying that so this server like let's say you are putting 500 servers, these many servers you want, and this is the capacity we want. And based on that, we'll make the auto scaling rules in such a way that based on so based on the numbers, whatever we articulate or we extract. So based on that, we'll put the auto scaling rules accordingly. Okay, so we'll see that. So database is independent of ALB, so that's where I'm starting the ALB. Our database is also in parallel. Really need not to wait until the ALBs are completely created. It can go in parallel. Or if it can go in parallel, I can necessarily change accordingly. So edit the pipeline, both can go in parallel just to make the things faster. Whenever we need it, we can get kind of a server. So after front end, you run this. Okay. So, and the database is also after front end, you run it immediately. Okay. After front end, actually ALB should be created. The workstation also can start in parallel. Meantime, we can kick off databases and then the remaining services also. So every day we are wasting some time around this pipeline. So probably next time, at least next week. So I think there won't be any problems. It will happen faster. So once the database is done, it goes a bit faster only. But until then, we can go to our front end. Okay, so these will come as a part of components. So database will fail, you know that, I think even waiting for 60 seconds also is it's not working, it seems. So after waiting for 60 seconds, we are running this one. Oh, sleep 60 seconds. So it is still telling that, so unknown MySQL host. I don't know what is the reason. Let's deploy it again. It will go through. Okay, it's done. Now it goes to the other components. So cart is done. Okay. So all components are done. Now let's go to the Nginx and try to restart Nginx. So still DNS problems. What it is telling is catalog -dev. Let's look up. It's there, right? So systemctl stop Nginx. Start Nginx. Yeah. So all components are up. The DNS is up. So now if I go to the load balance or target groups, let's start with target groups and go to the front end, go to the targets. At this point of time, it is still unhealthy. Let it come to healthy because we just now started the service. It becomes healthy now. Yeah, it's healthy now. Now I can just go to the this, and if I go to the public load balancer, if I put it on the browser, so you got it. So let's validate with manually. Local.com, Raghu, and then Raghu. Register. So let's take some product, add to cart. Cart is fine. Checkout, countries, something, calculate, confirm, pay now. The payment is going fine. Okay, so now we are ready to put the loads of the same way, however we did it yesterday, and we can do it here. So history grab docker. Okay, so yesterday I think we went it till 250 also. So 250 users, we'll just run for 1 minute and see. So yesterday load balancer and today's one is I think same. I think it should be the same name. No. Okay. So let's go to the dashboard and let's go back to last 15 minutes once again. Yeah, so you started getting the metrics. Okay, so here you're getting payment related issues also. So what are the payment related issues? Yeah. Too many requests, right? So you remember like yesterday also we are having some issue with the payment and we temporarily changed it to google.com. Okay, so let me do that. PayPal is actually kind of blocking us. Um, so vi/home/roboshop payment and then payment.py. So here we are having some paypal.com. So the paypal.com is actually going to be we changed it to google.com. But before do that, at least is that the reason? Let's take a look. So vim/var log messages. So is that the reason? Yes, I think PayPal only returning 429. Yeah, yesterday we already faced this issue and we kind of did it manually. PS-for kill -9. I'm just killing it because systemctl of this Python service will take little bit longer time. Systemctl restart payment. Okay, cool. So I just want to go to the meantime. So payment.py instead of PayPal, just some website, so which it can give some 200 response. Okay, now it is giving some report. So only ratings only we're seeing. Ratings is anyhow is okay because we are not using rating app. Okay, so this is okay. So that means for 250 requests, my systems are able to capable of running it. Okay, so now shall I double it basically? So like let's say I'll go for 500. Okay, so now we got the report, and the still report also says that it's actually only the ratings, the error report is, and it's kind of giving, so different components, and it's milliseconds response basically also. I think our number of requests it sent. So each some individual information it is trying to give. Okay, response time, so response time for percentiles. So if it is 100%, I mean, if it is 100%, the response is coming and everything is fine. So the cart responses are okay, and the card responses are okay. And how about payment? The payment is giving a little bit, so a little bit higher if you compare with cart and catalog. So but still it is okay. So 120 milliseconds is it's too simple. Okay, so usually we are going to have usually we'll be having I mean to say, like, you will be having an application performance defined by milliseconds. Okay, so we'll be discussing usually, or we'll be defining usually with some kind of a with a kind of a millisecond approach only. So how do you say that the application is performing well or not performing well? Depends upon its response. Okay, and the response is almost giving, like, in milliseconds. I'm still okay. Payment is also fine, and but yeah, ratings is anyhow is a failure. So shipping is also kind of okay. Only certain times actually it is spiking up in some cases, like, so some 310 milliseconds. But otherwise this response is also okay. Okay, but shipping cities actually is giving a kind of some, so bad response. So 10,000 milliseconds for so certain countries it has given. Okay, when it did it. Okay, so but that's also, yeah, this is the only thing we should consider, so how to make it a bit faster here. Okay, so how can we make how can we tune this basically? So since we are having only a single server, so handling these many requests, actually probably it is getting this much time, or it's a big database. First of all, the design itself is wrong. Okay, he took a shipping with a MySQL, and the MySQL database is a very big database, and there is no caching in between, isn't it? You understood the concept. So how my catalog and card services are much faster, because there's a Redis component involved out there. But with the shipping, he's directly talking to the database. Okay, so he's not really putting any kind of a caching in between. So definitely the spike will be there. For every request which goes, the database is kind of getting choked up. Okay, so let's look into the database states. So for this, we actually choose an RDS instances, right? So if we go there, so we have to tune the RDS also now, because the RDS is the one who is giving the responses, and there is no cache in between. So we have to involve the cache first of all. Okay, if you look into the monitoring of this one, so it would have some monitoring. So database connections are there. So the CPU utilization is kind of spiking it up at certain point of time. Only it actually came to certain time. After that it is okay. Okay, at what time actually this load was at 7:56 a.m. UTC. 7:56 a.m. UTC. Okay, so I think it's already 8:13. I think this is still okay. So on the cluster side, the resources are still minimal. Okay, I think at the time of creation or some time actually it went a little bit high, but after that it was almost like normal only. Okay, so now let me go with a certain long-term numbers. Okay, rather than actually 1 minute. So I will go for some 5 minutes. Okay, and I want to derive the outputs now. At least even after this time also, I don't see much load, but something is failing. We are already getting some exceptions. I don't know which component is failing, but something is failing. Let's see. Now we got the shipping error only basically. So this much load now we are getting on the shipping side. So error getting the codes and all. I'm not sure whether it is really responding or not. The databases is really responding or not. We're not sure because here also it's not showing any information. So 1 minute for, like, let's say if I go for just 5 clients, let's see what's the response. Now shipping is still, or let's look into the Prometheus side of shipping. So why it got timed out. I mean, memory side, it is fine, I think, but let's see. So now we are just giving with only 5 users, how it is responding. And also in the meantime, I just would like to log into the shipping instance. Station. And messages. So usually you'll find out some exceptions here. So here, so now even for five users, it's only giving kind of a ratings only. So it's not giving any problem. But before to that, we had some exceptions here. So what is the exception here is, so GC overhead limit exceeded. So this is something SQL exception. Okay, so actually in more number of connections, it's actually trying to do. And so GC overhead limit exceeded. So I mean, probably I'm not sure. So what need to be fixed on this? So we need to take the help of the developers in order to out of memory. Okay, so the memory issue is out of memory issue. Yeah, actually it should show out of memory. That's also okay. So now you're getting out of memory. So out of memory, directly not getting out of memory. you're getting out of memory. I'm expecting this. Yeah. So free -m, if I look into that, the free memory is still there. Okay, but it is free memory is still there, and it is consuming only 1301, and now it is saying that it is okay. So memory doesn't okay, so memory exceeded basically. So why? Because this Java service whatever we are using is really not taking the complete memory from the system. Okay, it's taking only a limited memory, probably 1 GB or some around that number it is taking. Okay, so I want to tell to my Java service, hey Java service, you can go ahead and use my 3 GB of RAM. So how do you set that particular one is by using Java. So Java min and max heap size. Okay, so value. So how do you set that particular how do you set that particular one is xmxx is nothing but the maximum value. I mean xms is the maximum value, or this is the maximum value, or this is the minimum value. So whatever it is, xmx is the maximum value. Yeah. So what I have to do is I have to pass these particular values also as a part of my Java. Okay, not only this much. So vam/etc systemd shipping system shipping dot service. So here I'm going to say that use the maximum values of 3 GB. So what is the 3 GB calculation? So yeah, 3 GB, right? So you're actually giving small g or capital G, I think small g. So which is 3 gig. 3 gig you take it directly, so you're telling it. Okay, so the memory issues will now systemctl daemon hyphen reload and systemctl restart shipping service. ps-ef okay, or free -m. Now you will see the system level free memory will go very low. Okay, why? Because actually I mean I think it should start consuming, or it didn't took it actually. Not sure now. Yeah, and small g only is fine. Okay, all right, let's give it a try now. Previously when we ran for 5 minutes only, we are getting the issue, right? The users of 500. Actually, did you observe here the CPU spike happened? Shipping 96% it went. So, and already I told you why CPU spikes will happen if there is a memory issue, or if it is a disk issue, or the whole CPU itself is used. Now shipping service is actually out of memory, so that's where there's a memory pressure, and that's where you got the CPU spike. And previously the memory was always 40% usage only. Now it is crossing. Okay, so since you gave the so you gave the Java to go ahead and use my 3 GB of memory from the system, you are telling it, so then yeah, so it is giving it. Now out of all these particular ones, so only so the service which is having some kind of a problems over here is our Java service only. So Java service is really not So Java service is really not that much performing like other applications. Other applications it is actually doing this because the design is also some problem. What is the design problem? There is no redis in between. Every time you are kind of hitting the database, it's kind of a lot of latency will be there on the application side. Now you should understand the importance of the caching. It's almost reached to 100%. Free memory is no more. So then free memory is no more, then started slowly again spiking it up. Okay, so now we got only the, so at least only the ratings report only. The shipping is, is all okay, it seems. And the response times are still bad. Of course, we cannot do anything beyond that. Why? Because caching is not there. That's okay. But yeah, so for now, so even the 500 requests are fine. With the 500 requests are fine for this particular one for 5 minutes if I run. Okay, so how about if I go with little bit doubling? Okay, so a little bit in the sense like 750 I will go for. So 750 requests if I run for next 5 minutes. So what is the response? I mean, I just trying to kind of bring some standard numbers because the other services are still okay. You see this? The other services are really not that much resource eaters. Only this service, Java, is out. So the Java falls under certain numbers because other services are very simple services only, right? The other services are, I mean, simple services in the sense those are running in the simple servers. Even the micro machines they are running. Only the shipping is only with a higher instance. The other machines are still in the lower instances only. So what we need to do over here is, so first of all, this auto scaling is must and necessarily needed for my shipping service. Okay. So yeah, we will come to that particular point. But before to that, can we just make some table because other resources are kind of no, okay, basically. So, but if I want to know that these resources also, so and there some saturation up to some threshold points, I need to put more load. If I'm giving more load, my shipping is actually dying. So that's where, so the shipping side actually I do require a little bit more instances. Okay. So what we'll do is first we'll do the manual scaling and we'll double the number again. Okay. And we'll see the performance of the shipping. Now, if you're doubling the instances, then the rules also becomes a little tricky now. Let's see. I don't see any exceptions so far. Let's see. Okay. Now if we see the report, so basically it's all ratings. So ratings is the only one which is having a problem. That's okay, and still we are able to sustain and with the maximum load basically. So even if I want to go beyond, so probably some 50 number I'm using, but the some latencies is are really bad. Okay, so 2900. So confirm the payments. So this is really bad actually. So to get the response of 3 seconds it is taking to get a response, the database is really not that much performing. Okay, but the raw ds performance in the meantime, so little bit. Okay, it's not that critical here. So this is still okay, it's sustaining. So this is also like database instance of a simple instance only. You just went with a small instance. Okay, so this is also okay. So the CPL load at least over here is this one, which is still okay, and write latency is also kind of a milliseconds, which is 2 milliseconds, and this is also okay. Right side database is fine. So my shipping time, actually shipping service, only the processing time it's taking more. So even if I can go with some higher number now, uh, but actually it should not consume that much memory. So that's another thing. So what I wanted to do here now is, before doubling the number, so I want to go with auto scaling group of so shipping manually. I want to scale to one more instance. I'll go to the auto scaling group and will manually scale. Yeah, so here and shipping. Okay, so we scale to 2 instances, so that means we're expecting a new instance. So we asked to, for 2 instances. Let's go to here. So the shipping second instance is actually coming into picture. And go to the target group. Go to the shipping, go to the targets. So let's wait for the other one also, come under servicing. And also in the meantime, I just want to show you something. So basically, so this is how, so when we, like, let's say I'm working for a consulting firm here, right? So when we are actually building up the application, so the major thing actually comes into picture is, so So key performance indicator. So how do we say that, so our application is working fine or not? And what are the key things that, when we finally deliver the application, what is expected? Okay. So here is the number of, things which are certain things which are actually expected. So here on the, basically on the development side, if you see here, somewhere you will see, yeah, here, you see this. So maximum order execution should be in between 0.5 to 1 second. Okay. And also some broadcast should be at 0.2 seconds. So that means in around 200 milliseconds. And now interactive messages is actually going to be less than 500 okay, so around 500 milliseconds. So this is what actually so the people generally look in when the application is actually made, basically. So that's what you need to understand. Okay. So yeah, and so that's the reason I was looking for the response times. Okay. So if the response times are higher, okay, so um, ultimately what we say, mm, the response times are higher, and ultimately what's going to happen is if response times are higher, your ultimately your application is not performing well. Okay, so that's what we need to understand. All right, so now I'll go for 2000 requests, so that's okay. But before to that, I want to look into my graphs, like how my graph looks like. So now I got two servers basically. So on this machine, the load is still so the memory is still 100%. Actually, shipping day is around 96% now. I'm just looking more of this only. So let's see. Now there is a second server also came in. I'm just looking like, why it is not coming up here. Let's see. Okay, so I'm hitting 2000 users now for the 5 minutes. So now let's see. I'm just looking for the other services. Shipping is okay. So shipping, we already kind of get already some threshold, like so some 500 users you want to keep in the system, keep in the server. So then you require a 3 GB of RAM. So if it is based on doubling, so you have to based on the number of requests coming out there, so you have to double it. Okay, so if the request, I'm just kind of like a benchmark with 500 users. For 500 users, the RAM size around, or even for 750 users also it worked, but I don't want to go that much thresholds. So, but 500 users is fine for my shipping service. At a memory of 3 GB. Okay, I don't want to go beyond and give it as well. So rather than that, I want to horizontally scale rather than vertically scale. So there is two things here, right? So vertical scaling versus horizontal scaling. Okay, so horizontal scaling versus vertical scaling. Okay, so now if you look into the images, basically, so what is vertical scaling and horizontal scaling is, so vertical scaling is in the same server, actually you increase more. Okay, you increase more. Rather than that, if you go for horizontal scaling, so this is vertical scaling. So one single server only, you're going to increase the capacity. That I don't want it. Okay, so I want to go with the horizontal scaling. So that means maximum number of servers I want to keep it. Okay, so that's the idea. So I want to go with scaling horizontally. In microservices, horizontal scaling is much preferred than vertical scaling, because yeah, so because the performance wise, and as well as and as well as scaling wise, horizontal is much better than vertical. Okay, that's the idea. So now we are putting the numbers. Now come back to Grafana. This is okay, but the load is actually getting into negative values. CPU usage is actually getting into negative values. Why? Because there are now two instances. Now there are two instances, and that's the reason actually this is I know our calculation is wrong. Okay, we have to tune that. Okay, CPU is okay for now, but I will just go and say that on the left side is actually taking some kilos, this one, but I want to say that it is percentile. You can go to the access here and you say that it's a unit is miscellaneous and it's a percentage which is 0 to 100. Okay, so save. All right. Now actually, why? Because you are getting that way is, so here I just need to look into the something. So I will just take a duplicate of this and I'll try some error trial and error method there. So which instance actually we have now? Shipping, right? We'll just take shipping and I'll kind of correct it. Okay. So yesterday, what we are trying to do, let's go to Prometheus. Okay. So you're getting something and rate of this one, you're getting some number. So which you are getting is some 121. Ideally, you should not get 121 for each instance. No, no. Okay. So actually, now I got the point. Previously, CPU 0 and CPU 1, and there is only one instance out there. You're getting shipping dev of one instance only. Where is another instance? Okay. Now this is each of two instances. Yeah, makes sense. So this shipping dev is actually two servers, isn't it? So each two servers actually you're having, so if you just go for node underscore load one, just try to execute it. So you're going to get a shipping dev even here, as it is actually, so since the name is same, it is actually kind of, it's for a two instances. But how do I kind of know it actually? Interesting. I think last time I did it something, I don't remember. But for now, I will keep this particular one is a wrong. I think I just need to look into the calculation what I did. I can get it from my previous batch. I did something to just to showcase there. I don't remember what I did, but we'll do it. Okay, it's not a big deal. But look into the memory. So memory is what our concern as of now so far. But if I just try to remove this, see others are reaching kind of 40%. Okay, kind of reaching 40%, but even some things are even less. So like front end and all is pretty less, even on these numbers also. And if I look into the output, so shipping again crashed. So saying 504s. Okay, so if I go to that particular number, so and the graphs are now completely wrong. Why? Because those are kind of, we are actually giving two servers. Those reports are quite wrong. So I think we did a decent understanding. So I want to come with a benchmark. Okay, so simply a benchmark values. Now I want to say that, so even though I went with the 2000 requests, so 2000 requests are there, are okay for even for, so cart service. Okay, so 2000 requests are okay for, catalog service, and 2000 requests are okay for user service, and 2000 requests are you okay for front end, and even 2000 are okay for payment as well. But 500 is only okay for 500 is only okay for shipping. Okay, so But what is the resources? This is 1 CPU and 1 GB of RAM. This is 1 CPU and 1 GB of RAM. This is 1 CPU and 1 GB of RAM. Are we using the right things? Let me go and check it out. So let me go to the instances. Front end. It's actually T2 micro. Yeah, I think T2 micro is 2 CPU, 1 GB of RAM. Instance types. T3 dot micro. It's actually 2 CPU, 1 GB of RAM. Yeah. So it's actually 2 CPU and 1 GB of RAM is fine. But this is a bare minimum instance I'm taking, and 1 GB of RAM. So 2 CPU and 1 GB of RAM is fine. 2 CPU and 1 GB of RAM is fine. But this is 2 CPU and 4 GB of RAM is needed. Okay. So because we went with T3 medium. All right. So T3 medium is 2 CPU and 4 GB of RAM. Okay, we want so 500 requests only we want. So based on this, okay, we want to set up our auto scaling rules. So that I will, okay, so I will push little bit aside because I want to do that. But before to that, no, I also want to look into the responses of my application. Okay, I want to look into the responses, but I'm looking kind of from the so I'm kind of looking it from the what we say, so from the report of the my load runner. Rather than that, I want to actually track from the application. I want to put a graph on the load average. I want to put a graph on the load average. So, okay, this is how my load average is happening. The same way the Prometheus, whatever the way you got it, the same way, okay, I want to get it. But how do I get that? How do I get that? Okay, so that particular thing you can get it from the logs. Okay, so if I just go to the logs, okay, so logs will give the information. So tail -f /var log messages. Okay, so this kind of gives some information. So or probably rather than this from here, you can directly get it from front end. Everything is actually logged on the front end side because that is the one who is proxying everything. So you can just go here and say SSH, this one, and tail -f /var log messages. Right now, tail /var log nginx and then access.log. So this actually goes and gives a response. It's actually doing every call and actually it has some response involved here. So response times. Actually, it's not having the response time. We can ask for the response time from the nginx. Nginx also prints the response time, and I can take that response time and I can identify, okay, how each and every call is actually happening to the backend application. I'm going to take that particular application. I'm going to take that particular values. I'm going to kind of put a graph there. I'm going to kind of put a graph there. Okay, so how do you do that? How do you do that? So I have to collect the logs and I have to put it to the graph. Okay, so that is one thing. So I want to collect the things, and I as a part of my application monitoring, I need the logs and I'm pulling it. So that's one part of need for getting the logs. And at the same time, so these servers are much volatile. So that means they'll change every time. So it's an auto scaling group. It creates the server, it destroys the server, and things are there. Okay. So when certain things are there, so certain logs might be missing, or so every server I want to collect the logs. Okay, how do you do that? Every server I want to collect the logs. How do you do that? So each and every server I cannot go and copy the logs, right? So there should be a standard mechanism. So where I'm going to collect the logs of each and every application which I'm running out there, and I put it in a center place. So that's where the log aggregation comes into picture. I want to bring the log aggregation, and based on the log aggregation values, then I want to finally say that, so these are the auto scaling values. Okay, until then, okay, I want to push the auto scaling group little bit aside. And so this Prometheus also will fix it later. In the meantime, I'll take a look, but most probably the next session will start with the log aggregation, so which is the Elasticsearch. Okay, how do we pull the logs, and how different logs are having different formatting, how do you deal with them? So those particular parts also we're going to talk, and we will try to put it in. We'll try to put it in Elasticsearch, and we'll kind of generate some reports, and we'll understand the reports from the application actual performance also, and then yeah, we'll come with some values. But until then, so this is what we our decision basically. So that might impact a bit. I mean, that might impact also some changes inside this, but for now, this is okay. Okay. All right. I think that's all from my side for today. So at least you understand something. How do you design, right? So when you say the capacity, how do you design? So this is how you do. This is some load test usually written. So based on you run the load test, you get a report. Based on the report, you understand. Okay, this is how this application is actually um, behaving. Okay, right. So yeah, probably on Monday. So we'll start with Monday. We'll start with um, log aggregation. Okay. Yeah. So that's all from my side for today. Any questions? Okay. All right. No questions. We'll meet in tomorrow's session, and not tomorrow, day after tomorrow, and we'll continue from there. I see a question on the chat. So we all, yeah, so is as a part of okay, so is a part of release to the production or release to the customers, right? So you kind of in the development phase only, you will design all these particular things, and finally, you'll be ready with these particular details, and you operate based on them. Yeah, you're right. Yeah. Okay. All right. So see you on Monday. Bye. Good day. Good night.